Hi everybody, this is Mrs. Ellsworth. I'm going to be reteaching that harmonics calculations part of our unit here. We had some really great scores and some low scores, so that's okay. We're just going to deal with it, throw that out, and we will get another sheet for you to do online, and that's okay. Let's go back and go through these ones that are on that worksheet that you did electronically, and let's go and figure them out. Let's start out with the first one here on that worksheet that you did online. What is the fundamental frequency of a 0.20 meter long organ pipe that is closed at one end? So that means that we'll be using this formula, okay? When the speed of sound in a pipe is 352 meters per second. Now, you're going to be using this one so it doesn't have a second frequency or a fourth one. If you would ask for the first three frequencies of it, that you'd have to do with a 3 in place of n and a 5. There is no 2 on this one. The other two, there are. Since this is our COVID time, I didn't go and spend too much time on worrying about that, so I kind of cut the unit a little bit shorter, and so we will not be dealing with this in our work that we're doing right now. Okay, so let's go ahead and look at this. We've got speed of this case right here, and other ones it's got different numbers, so you always have to watch what it is because it has a lot to do with the speed, has a lot to do with how fast that the air is going in, and also how much heat is in it too. So you really have to watch what the speed of sound is in the different types of instruments and other things that are producing sound. Anyway, so let's go ahead and look at this. So we've got F sub n, which the n will be 1 in this case because it's fundamental frequency. They're always ones, okay? And so we'll go ahead and put this here. Okay, and so then we have to fill in with the speed, which we know is 352 meters per second. Okay, and then also the length is already in meters. That's perfect because we need to have meters. So that works for our formula, and so we'll go ahead and calculate that. So pause, calculate that, make sure that you're using your calculator correctly. Remember, this is a 1 here because it's fundamental frequency, so it's really basically a 1, so you really can ignore it, can't you? You can just, it's just a 1, right? Okay. Okay, so when I calculated this, I got there's 2 sig figs here, 3 there, so our answer has to have 2 sig figs, but that's what I got in the calculator. Now I did notice that some of the results that students had on that worksheet online that they had decimals, and so I'm wondering if when they did this that they should have had parentheses down here so that they were a little bit more successful with the math of this. So if you would have had parentheses down here 4 times 0.2, that you would get, a larger number than 352. And so I was wondering if that was part of the problem. You need to put these in parentheses 4 times 0.2, and you should get the 440. Now, if you're somebody who got decimals in all of your problems, I want you to work these out with your calculator now as we were talking about them, because if you're having difficulty getting the correct answer with the correct variable numbers for the variables inside there, that's a calculator issue, so that needs to be addressed. Okay, I'm going to go on to number 2. Okay, let me get a pointer. Here we go. So in this one, we've got a flute is essentially a pipe open at both ends. So we're going to be using this formula. Let me get that out of the way. It's open at both ends. This right here is our typical one. It's the same exact formula as our vibrating strings one. And so let's go and finish reading this. Now, a flute is essentially a pipe open at both ends. The length of the flute is approximately 66 centimeters. That is also 0.66 meters. Okay, for the length. Okay, what are the first 3 harmonics? So we need to figure out F sub 1, F sub 2, and F sub 3. Okay, but we'll first of all start out with our fundamental one. Okay, I better finish reading this, sorry. What are the first 3 harmonics when all the keys are closed? The reason why you say all the keys are closed, because that means that the air is going to go through the whole flute without some escaping out a hole, so that you know what the length of it should be, because it changes the length as soon as you open up some keys. Okay, making a vibrating column approximately equal to the length of the flute. What is the speed of sound in the flute? The speed of sound in the flute is 340 meters per second, so that's our speed. So there we go. Okay, so in this case right here, we're doing just the fundamental frequency. So let's go ahead and put a 1 here. Okay, and a 1 here. Okay, and I just wrote over it because really, as soon as you put a 1 into an equation, you're really just kind of ignoring that space because it's times 1. Okay, so here we go. Fundamental frequency. Here's our speed. Okay, speed is v. There we go. And then our length is 66 meters. And so when we go and calculate this, again, you take 340 and then times and put this in parentheses. Okay, and then divide by that number, and you should get your fundamental frequency to equal 257.57, I think it's 0.58 actually, hertz, and we have 2 sig figs in here. This one's 3, this one's 2, so you gotta use 2 sig figs, so it'd be 260. Okay, so let's go ahead then and look at the second of this. So the second frequency. So it's 1 higher than the fundamental in this case. So let's go ahead and look at that formula. Okay, and now this time, when we go and we put our 340 and our 66 meters in here, okay, now we need to look at this guy right here. Okay, this is not the first anymore, it is the second. And I should have wrote that in here, but oh well. Anyway, this is times 2 now. So it's times 2 of all of this. That's parenthesis, by the way, that ugly mark is. Anyway, so really what are you doing? You're taking this whole amount, same thing, and you're multiplying it by 2. You can go through all the math, do 2 times 340, and then divide it by, put these bottom ones in parentheses, and 2 times 0.66. But what you're really doing is taking this fundamental frequency and multiplying by 2. So when I did that, I got the the second one to be 515.14 hertz, or at 2 sig figs, 520. Okay, so let's go ahead and look at the third one because they want the first 3 harmonics. Here's the third harmonic. Okay, now this time it's not fundamental or a second one, it's going to be the third one. And so we've got a 3 here. I'm sure that you might be able to recognize that we're going to take 3 times the fundamental frequency again because they are the same exact numbers. Okay. Same exact numbers is 3 times that, isn't it? It's 3 times this whole fundamental frequency. So you didn't even have to write this out. You could go take this number times 3. And you can, and you'll get 772.72 hertz, or 770 when you do 2 sig figs. Now, did you need to go and write these things all out? No, because you can understand that you take the fundamental frequency times 2, the fundamental frequency times 3. So that's how you find the harmonics. If this would be a different type of situation, like the first problem where you had this, you do the same exact thing, but you do 1, 3, and 5. And we're not really hitting that hard with it with our COVID distance learning going on right now. Okay, I'm going to move on now to number 3. Okay, what is the fundamental frequency of a guitar string when the speed of the waves of the string is 115 meters per second? Okay, and the string's lengths are as follows. So when you put your finger between some frets on the guitar handle, I can't think what it's called right now, but when you go and put your finger at different lengths, it changes the length, and so you get a different frequency, you get a different pitch, a different note. Okay, so let's look at this. Oh, they've got them in centimeters. We have to change that into meters. Okay, I'm going to do it for all of them right now so I don't forget. And where is that 0.5? There it is. Okay, so we're going to go with those ones instead. Here is our formula. Okay, and you should recognize that. And so in each one of these, the string has its own speed, and it will have it because it depends on the string's thickness and how tight it is stretched to determine what its speed is. Excuse me, there I have an error there. So, okay. So, okay, there. Anyway, so we have to finish filling out the formula, and so we need to have the length of it. The length of the string in this case right here is 0.700 meters. And so when I go and calculate that, 115 divided by this multiplied value down here, so make sure you put parentheses on there. I'm kind of worried about that. Okay, I would get 82.1 hertz. Again, go and double check that with your calculator. Make sure you are calculating and using your calculator correctly. Okay, so then now we'll go ahead and look at our flute again. And here we've got a fundamental frequency again of 1, 1, and 1. Okay, we've got the same exact string speed. I had said flute, whoopsie, it's a guitar. Anyway, so let's go ahead and put the length down here. So this is our second calculation out of 3. Boy. And so when I go and I calculate that, this does equal 1 down here. So this will equal 115 hertz. Okay. Now I'm going to figure out the fundamental frequency at 0.4 meters. So here we go. And same exact string speed. But now we're doing it at 0.4 meters, so it's going to be a little bit less than this one over here. And so when I go and I put that into the calculator, I get a value of 114 hertz. Make sure that you can get those values with your calculator. Okay? Okay, let's go ahead and move on down to the next one. Okay, there's another string problem too, so we'll be using the same exact formula. Okay. Oops, strings were over here. Anyway, so in this case right here, we have got a violin string that is 50 centimeters long. So again, that is 0.500 meters and has a fundamental frequency of 440 hertz. Okay. What is the speed of the wave? So now we're going to have to go and change this around and manipulate it around. If you had trouble doing that, I'm sorry that we didn't do that in class, but also we don't need to worry about the two ends there because again, they are just ones. Okay, so we don't need to worry about that. And of course, that's telling you which one that's identifying the type of problem. Okay, so we're going to go ahead and solve this looking for the velocity because that's what this problem is asking for. It's asking the speed of the speed of the wave. So I went and put it all together there. We got the ones in there, and then now I'm going to go and manipulate it. So f sub 1, I didn't worry about this one in here. F sub 1 equals well, f sub 1 or just the frequency times 2 and then times the length, and that all equals the velocity of that string. Okay, and then I went and moved a little bit further. Okay, and I left that open because I'm going to go and insert those variables up there. And so I've got, let's get rid of that. I've got the frequency is 440 hertz and the length is going to be 0.5 meters. And so when I calculated that in the calculator, just multiply it straight out. I went and got 440 meters per second, or at 1 sig fig here, we've got 50. That's only 1 sig fig. So it would be at 400 meters per second. Okay, so that's a tutorial to help you. You can go ahead and go back and wait. I have to shut off that that worksheet now, but you can go ahead and look at this and ask me if you have any questions, and I will get another worksheet to replace those questions as soon as I can. Okay, I'll get there. And so I'll get there, and then you can retake that and get a better grade. Okay? Ask me if you have any questions. Somebody had made a comment that the formulas were hard to see. And so I know that they were also written in your notes too. This was typed up in your notes too, in that notes packet. So it is there. Put it on your formula sheet. I don't know what else to do to help you with these unless you ask me specific questions. So if you've got any, let me know either through private comments or however. Okay? See you later. Bye-bye.